everyone, welcome back to our YouTube channel Becoming a ROS Developer. I'm Desire and today I've got Ioana who has completed the course ROS2 Basics in 5 days and she will be giving us a presentation on this. So what I'm going to do is to hand over the platform to her so she can begin a presentation. Alright,
Cool.
we can start, Ioana.
Yeah, thanks for having me. Yeah, so I built I compiled, I sourced, and now I'll just run basically launch the program.
Okay,
The package is will follower, and I have all the nodes here in LaunchPy. Okay, now it takes some time to start. So the first thing it does is kind of rotates itself to find the closest wall.
mm-hmm.
I mean, we're gonna talk more about this here. I guess I could have done it to turn either left or right, depending on where it is. I always turn left.
Okay,
So that means that sometimes it kind of does a bigger loop.
okay,
Um, okay, so now it's kind of driving. Um, it's either, so when it's driving, it basically kind of looks at two things, whether there's a wall in front to align itself to the new wall,
mm-hmm.
or if there's no wall, then just keep on going straight. I mean, of course, there's sometimes like small obstacles, or like the robot's like velocities are not perfectly registered. So it's good to actually not just let it run fast straight. So to kind of always check the distance to the wall on the right to know that it's okay, to avoid crashing, or to avoid crashing into an object, or to avoid like drifting too far from the wall.
Okay, okay. I
Now,
see. I see
yeah.
that sometimes it stops and rotates. Can you tell me what was the reasoning behind not using compound movements? Because I think you advised to not set your linear velocities to zero when adjusting the trajectory.
When adjusting to the
When
so
correct,
what do you mean?
when
So what I mean, what I did is kind of to measure the distance to the right in terms of like is it 3 centimeters, 2 centimeters, or in between.
hmm
Um, that's what I meant uh, to do. But what do you mean by compound velocities?
So you have your linear and angular velocities being set to a non-zero value when your robot
Mm-hmm.
is attempting to correct. It's to reduce the distance between it and the wall or to increase the distance to within the allowed
Mm-hmm.
tolerance, right? So either
Yeah.
0.25 or 0.35. So my assumption is
0.25. So were these values given? Because yeah, I mean, I kind of played around with some values to like not drive too fast, too slow, or um,
yeah, that's fine. I'm not saying you
okay,
had to use
okay,
exactly those values. I'm just asking
uh-huh.
why did you choose to have it stop first and then correct the heading, the trajectory for which it's following?
But I think it's not stopping. I think maybe it's just no, okay, sorry. It's because here when it's very close to the wall, basically I kind of used so I used this kind of linear scaling up or down. So if it's like very close to the, so I guess you see my screen.
Uh-huh.
Um,
Yes, yes,
so
yes.
I have
Okay.
a forward speed, which is kind of a value I set, and then here in the branch where I'm really close to the wall, I might scale it down.
Okay, so
Uh,
I see. So this scales it down to some value that is way lower than zero point 0.1, right? So sometimes it looks like it's actually rotating in place. And then in some
mhm.
cases okay, I see. That's a very nice implementation, by the way. It's just that it happens more often than not, right? So when you look at it, like I'm doing, it
Yes,
looks like it's stopping and rotating. Okay, I see.
and I think actually, so the first thing, we had to make it work in Gazebo in the simulation, and there
Correct?
actually, I mean, I noticed kind of you switch the, I mean, it's like now a different robot. I mean, this one is the Flashbot, and in the Gazebo is the Turtlebot.
Yeah, yeah.
Which I'm not sure. Maybe they're like maybe this, but in when I started, ran my code in Gazebo, like the first implementation ever.
Mm-hmm.
What would happen? The robot would just crash like many times. kind of start to, not just stopping or like being stuck on the wall, really, falling down, and then I would have to restart the simulation because there will be no way to to drive the robot back. And I think there I realized, okay, I really need to, avoid crashing into the wall.
Mm-hmm.
And that set me up to this. Here, the robot is more stable. I don't know. I mean, one, maybe the walls are a bit more soft. Also, and then second, yeah, it has more, because it's more like the turtle boat is very vertical, so maybe it's easier to like tilt. Um,
Yeah, okay. So, I mean, I want to understand in a bit more detail, like when you say that it crashed often, right?
mhm.
Was it because did you check how the LiDAR indexes were set or where your indexes were starting? I think that's
um,
where you probably have found your answer. So I'm going to probe in that direction. What did you find, and did you eventually get it to work? Maybe you can switch to simulation and see how it's behaving there.
you want to run in the simulation now?
And sometime later, right? So we still have
Okay,
got
yes.
some time. Yeah, but I want to
Um,
see your perspective
mhm.
on this.
Yes, so I think the initial thing was that, these velocities, I mean, also, I mean, because I don't really know the scale of the simulation of the robot. In the beginning, also zero point 0.2 linear velocity, is that driving too fast, too slow.
Yeah,
I
yeah.
think the main problem was so the main problem was really making it drive too fast, and then it would drive too fast and then turn left, and maybe it would kind of lose balance. I think that
Okay.
was one thing.
Yep.
Then the second was also the LiDAR, because also I'll kind of go a bit deeper into this. I was using in the simulation, one index to one angle, and then I kind of switched to a sector to kind of look over a range of LiDAR readings. And this
Okay.
also maybe made it a bit more stable. And, if the wall was missed by one laser reading, it would be kind of caught by the others.
Okay.
So
Okay.
this was kind of the second thing that I adjusted. And third, but in the end I didn't go through that, because it was really, I mean, it was also the first time I would kind of deploy something in a simulation. And I was starting to keep track of the basically of the tilt of the robot.
Okay.
Because in the beginning it really gave me the impression that it's very fragile,
Right.
the turtle boat in Gazebo. So really, I had this thing where, like, if it would start tilting too much, I would like slow down to, to avoid crashing and then restarting the simulation. So I would have kind of a way to prevent this kind of slower iterative loop where I would have to, yeah, really restart.
Okay. So in this, on the real robot, using the first word, are you still using one index or are you using a sector of indexes?
I'm using a sector of indices. Once I
Okay.
switched, it just seemed more stable, and I just went with it. Yeah.
All right, and can you take me through how you make your robot find the wall, right? Because I realized something very interesting. It did not have to move away from the wall to find it, right? So I want to understand how did you do that?
Yes. Yeah. Of course. So we can. Um,
Yeah, maybe
so yeah.
just
I mean,
maximize the whole window so we can.
yeah. Of course.
All right.
Um, I mean, of course, I'm kind of also talking about this in the presentation, but it's maybe, I mean, I kind of, in the presentation, I have pseudocode, so I would rather kind of show this if we're anyway kind of talking about it now. So
Okay.
the laser callback, basically, so I have these different sectors, and this also kind of going from a simulation. No, you know what, actually, let's talk about what you asked, and then we can talk about so the idea is that I have these different sectors,
Mm-hmm.
and within each sector, I look at for what's the closest object, and that kind of the minimum distance becomes the representative of that sector.
Okay.
Um, and now, so that's the kind of laser callback. That is what the laser callback, takes the incoming LiDAR data and extracts these two variables,
Yes.
closest sector and lowest distance. And
Okay.
then basically in the kind of the logic that moves the wheels, um, until I find the wall, the idea is to really kind of, the robot starts turning until uh, the closest sector is in front.
Okay.
And once it's in front, then I have two possibilities. If it's far, then drive towards the wall slowly.
Okay.
Otherwise, otherwise it means you are close to the wall. So just
Return true. Okay.
return through. But now, of course, we're like driving into the wall, so we're kind of have to also align the robot so that it drives with the wall on its right.
Oh, that's right. Yeah.
Um, and here, if the wall has been found, then and the distance is to the right is kind of a bit higher, then it should continue turning so that it kind of goes from being the wall in front to being the wall on the right.
Right.
And this is also in the end a small sector, so not one index, just kind of 10 degrees on the right of the robot.
Yeah. So what I was going to ask you on this one was that how are you guarding against the fact that the closest obstacle might be something that is not the wall, right? Um,
Mhm.
yes. How are you doing that?
So yeah, now it's kind of not really handled. So for
Okay.
example, if I put it close to this, oh well, I mean it's kind of so. I mean it's built for this arena, of course,
Okay. Yeah. 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 That
and
that makes
now
sense.
the idea is that, of course, I mean, so it could be this wall, and then it will
Right.
try to align itself to this wall on the right.
Uh-huh.
And then, the beginning works well because the kind of the primary navigation node where the node is on the right, here it's easy. The problem is here it kind of gets a bit confused, I guess, which one is I mean, it's trying to find a wall on the right, and there's no wall on the right. And
Mm-hmm.
but it will turn back. Uh, it will kind of do a loop, but yeah, it's not very reliable. Now, the
Okay.
fact that, I mean, here, if, for example, this object would be here,
Yes. Yes.
um,
That's exactly the
it
case
will
I wanted
not,
to talk about. Yeah.
exactly, it will not, I mean, the fact that I'm looking for, um, yeah, no, actually, you're right. I was gonna say that the fact that I'm looking within a sector is handling this, but no, because it will register this object as the closest.
Mm-hmm. Mm-hmm.
Um,
Mm-hmm.
yeah, so I think probably the way to solve this, where I mean, within a sector, we need quite a few indices to be to register the obstacle. That's how
Mm-hmm.
I
That's how you
I would
deal with
probably
it.
solve. Yeah.
Okay. Okay. Yeah, it makes
Um,
sense. It makes sense.
um, I mean, actually, because I mean, yeah, I am kind of counting this, but I'm not sure if I used it like intensively, or like I'm not sure if I really tested the whole thing with what we talked, like if the obstacle is on the other side. But
Uh-huh.
I am kind of counting this how many distances are within are less than. But I'm doing this not for the closest sector, just for the distance to the right.
Okay.
Um,
All right.
yeah.
So, I don't want to take much of your time. I understand you had slides that you wanted to use. Is that right?
Yeah.
Okay, so let's skip to
Um,
those and then you can run through them while we still have time. Yeah.
Yeah, I mean, I'll kind of now since we talked, I'll kind of skip the things that we talked. Yeah, there's no reason to, and you can ask, yeah, something else. So
Sure.
just to say, yeah, this was part of the ROS2 basics in Python, and the project idea was to basically develop and deploy ROS2 nodes written in Python on a mobile autonomous robot.
Mm-hmm.
And first we tried the simulation, and then once that worked, we could try the real robot. And the project was kind of divided in three parts,
Mm.
each kind of targeting different ROS2 foundation
Yes.
topics. So the first one was to basically follow the wall in a reactive way. Yeah, using topics. Then the second part was to basically align itself to the wall so that the wall is on the right,
Mm-hmm.
um, using services. And the last part was odometry tracking. So basically using actions to track where the robot is at each time and stop after we had completed a loop.
Okay, so
Um,
about this, right? So this was also an interesting point. I also noticed that your robot stopped a lot earlier. Can you tell me what might have happened there in the course of your explanation?
yeah, okay, let's maybe go. No, or maybe I want to say first. I want to see that I haven't like made a mistake and left the wrong threshold, but I
Okay,
don't think so. Um, no, its distance to start should be zero less than 0.05. Um, yeah, I mean here I have kind of two things to mention.
okay, go ahead. Yeah.
First was that I kind of so now we're in the loop where the robot basically when it's everything else checks out, the robot is in the initial position.
Mm-hmm.
It registers, okay, here is where here's my initial position,
Mm-hmm.
um, and it initializes this first odom, the first odom values.
You're right.
And then it kind of, while the action goal is active, it kind of tracks, it drives, and always registers the new odometry, and computes the distance to the start. One
Okay.
problem I had in the beginning was that the robot was overshooting, and now of
Yes,
course
that's why I
I
was
made it so that
asking. Yeah, that's why I was asking. How
um,
did you get it to stop that quick and maybe slightly earlier?
yeah. Exactly. Usually it would overshoot because I would have here too big of a loop. I would wait 1 second, and with the
Ah,
speed of
okay.
the robot, it would kind of drive past.
Okay, okay.
Then the other problem, then I made it to check like 20 times per second and update its values, and then it worked.
Right.
What I noticed that what I it would maybe work in the beginning of the like session, and
Mm-hmm.
then later on it would again overshoot, and actually just keep on trying. I would see the distance to start would kind of go down, and then all of a sudden it would start increasing without reaching this minimum value.
Uh-huh.
And there I noticed that sometimes maybe this odometry, so the odometry callback,
Mm-hmm.
maybe it doesn't initialize between the runs. So maybe I would use kind of, so this first odom is really read from basically what the odom callback gives me, and maybe here the robot did not yet in this current run, it did not yet receive this information, and I'm using the
Right.
one from a previous run.
Yeah, because it's
Uh,
happening asynchronously. Okay, okay.
yeah, so then here I kind of whenever I restart the program, I'm like I'm setting this, okay, the first time I'm entering this callback, I set this flag to true. And now here I'm really waiting until I have received the first package, and only then I go on with the rest of the code.
Okay, okay.
Um, but now this stopped early, and I'm not sure. I guess it started somewhere here. Um,
Yeah, that's
yeah,
why I
the,
was
it's,
asking, right? It started exactly where you placed your mouse there. So that's why I was trying to figure
yeah,
out what might be happening. So yeah, the good thing is it
it stopped.
worked. It's just that the tolerance is a bit too much. But anyway, no worries. So let's go on with this
Yeah.
presentation. We have got about 7 more minutes to go. So
Okay, great. So, okay, so then the odometry. So now, kind of the wall follower is the primary navigation node. It has these two parts, which you already talked about.
mm,
The incoming data kind of triggers the laser callback.
mm-hmm,
Um, it does that by establishing a subscription to scan
mm-hmm,
the topic, and then these two values, distance to wall and distance to front, are used by the control logic to kind of do the right thing, either turn left or kind of steer in a safe way with respect to the wall.
mm-hmm.
Um, and if this is the robot, in the beginning I had distance to front to the just 0 degrees, and distance to wall to the right. But then kind of the problems that I encountered here were basically related to the LiDAR information. One was that sometimes LiDAR information was either missing or it was just noisy. So
Yeah.
that made me kind of pivot to these sectors
Mm-hmm.
where the distance to front is like a narrow, because if it's too big, then you're kind of registering the wall to the right.
Uh-huh.
So this is distance to front, 10 degrees, and distance to right is like a bit more generous. Um, the over 60 degrees.
Okay,
And
so
the second, yeah.
let me ask just a small follow-up question. For your
Hmm.
distance to front, how wide is your sector there?
10 degrees.
10 degrees, right?
Yeah.
And did you not have a problem with it clipping other parts of the lab, or maybe you didn't run into that issue?
No, no. But maybe so the thing is, I mean, you saw it, it's not like super smooth. So I think maybe what happens is that maybe it kind of not registers it correctly on one like clock run, and then
Yeah,
immediately the robot drives a bit more, and then
it realizes.
it's corrected. It's
Ah,
corrected by the next measurement. I think that's what's happening because
okay, okay.
yeah, I mean, it never kind of crashes into the wall, but it also sometimes drives a bit too far from the wall, I would say. I mean, it doesn't really stay in the lane perfectly.
Yeah, no worries.
Uh,
And what at what frequency is your control loop running? Are you using 30 Hz, the standard one, or?
yeah, I'm using the standard one for this.
Okay, all right, good. Okay, let's go on.
Then is the variable length array length for the LiDAR. So in the gazebo, it would always have the same number of LiDAR. This array would have
Indexes,
this
yeah,
index 6. So a static index to angle was correct, like give me index, 20.
every time,
But
yeah.
in the every time, but in the real world, it's variable. So you have to use kind of the metadata to compute it
Okay,
for
okay,
each
very, very
for each.
nice. I like the observations you're bringing about because then it shows that there was a lot of engagement between what you are trying to do and realizing the limitations of the kind of
The,
processing or the pipeline that you have to build. So that's very nice. It's a very, very positive thing. So well done on that bit.
Thank you so much.
Right.
Okay, the second part, the services. So now basically we're bringing a new node, and the wall follower, the primary navigation node, then establishes kind of this service connection with the wall finder,
Mm-hmm.
where the client is the wall follower and the server is the wall finder.
Yeah.
Using a custom interface, and the idea is like kind of briefly the wall follower, you turn it on, and then before it does anything, it kind of sends an empty request to the wall finder to turn around. When the wall finder has finished turning around and it has found the wall found, sends
Mm-hmm.
back the response, and only then the client can go on.
All right.
And then, oh, I went back, sorry. Yeah, the same kind of as we talked about, we have the laser callback. I used the sectors, and the find wall callback I already explained. First it drives to the wall
Mm-hmm.
front, and then it kind of rotates.
Okay.
Um, Here, two problems. One was actually the first one was only when going into the real world.
Mm-hmm.
So basically, the idea is, the robot finds all these sectors around and the minimum obstacle, and it should rotate until the closest sector is in front.
Yes.
Um, the problem is that in the robot it was picking up something in the back of the robot, and the robot was keep on going and never kind of managing. First I thought it's again something with the clock, that maybe I'm like speeding too fast and the
Ah.
robot is measuring, but it was not that. It was kind of really picking up something on the robot itself.
Yeah. Yeah.
So I
Did you figure
increased
out
the
what it was?
threshold. uh, no,
Did you
maybe
fig?
the cable
Yeah.
that's
Yeah.
going
That's
up.
it. So
Yeah,
the support column for the cable, that's the one that trips up a lot of people. So yeah. Yeah. That's it.
exactly. So then I just increase, like, okay, give me something that is above this number, not something um, that is so close.
Mm-hmm. And
That's how and yeah.
yeah, and speaking about this, right, there's one question that I had lingering. I wanted to ask you, so you spoke about the fact that indexes, right, your indexes would vary for each sector on the real robot. Can you explain in a bit more how that is happening, right? Because clearly you understand that it's happening, but how is it happening? Yeah.
Yeah, I mean, I think the lidar is kind of going around, but it doesn't necessarily. It's not so. There's some angle increment between two readings,
Mm-hmm.
and then you kind of divide technically homogeneously the space around the robot. But it
Correct.
might be that some laser just don't pick up anything.
Uh-huh.
That's one problem. Sometimes there is just infinity if they're like too far away.
Right,
So
right.
that's yeah, that's one. Yeah,
Yeah, very,
that's why
very,
the
yeah,
length.
very valid, right? Because that means you would have to do the filtering of those values out of your sector, which means your sector will end up with less indexes, correct?
Yeah, yeah.
Okay, all right, let's go on.
Okay, and finally, I mean, I ran into a deadlock. I mean, service is kind of a synchronous communication by nature because it's short term, and the client pings and then waits until gets the answer.
Yeah.
So first, I had kind of here in the send request, I had used the synchronous communication, so it only call. But then basically, the robot would turn around and not do anything. I switched to an asynchronous, so that's kind of how I solved it, and then it worked.
Okay.
But I think I could have probably used the synchronous connection, but just kind of open a new thread.
Exactly. That's
Um,
what I was going to ask you. Did
yeah,
you find what was the cause of this blocking? And there is a way you could fix it, which you have just said. So
yeah.
it's interesting that you discovered this and you still found a way to fix it. But I want to ask you, what are the drawbacks of your current mechanism of fixing that issue?
Um, I mean, one drawback would be that the robot might start driving, kind of doing the functionality of its own node while kind of aligning to itself, to the wall. But that's the problem I didn't have because I'm kind of waiting for the request to set some flag in the navigation node, and then only then I'm driving.
Okay,
Um,
okay.
so that's one problem. The problem, like, so this, I changed it, it worked, and then I kind of moved on. But then I kind
Yeah,
of
yeah.
thought about, why doesn't it work, and how it would have worked. And I think the problem is that here the client, kind of, if I use synchronous and I don't open a new thread, the
All
client
right.
kind of sends the request, but then there's no kind of this, so this kind of blocks the main thread, and there's no opening basically for to go further, to start spinning this node and get the answer.
Yeah,
Um,
yeah. Yeah, so
so
it would
that,
just create a future object, but for you to have valid data in that future object, that's the only thing that would trigger a continue processing, right? So
yeah.
it's still kind of blocking, but in a way that is workable, I would say. So this is where I wanted you to explain in a bit more detail what are the drawbacks and okay, so how do you think multi-threading would fix this issue? Like just in general before we wrap up?
So opening a new thread, you mean?
Yeah, yeah, yes.
Um, then I mean, there would be you would have a background thread that would kind of spin the node and would be basically waiting for the future, for the
For the return value.
response,
Yeah.
return value.
But then you also have to guarantee that your robot doesn't start doing things before the return value comes.
Um, yeah, but I mean, that's kind of, I had this flag that the robot would basically
Right.
ignore everything until the maybe I'll just kind of show you. So this is kind of after so then how it connects also with the action, and only here. So first it has to connect with first it has to wait for the server to finish,
Yes.
and then it has to kind of connect again with the odometry node, and
Right.
basically only then becomes this client active true, and only then basically the control logic of this node starts.
Yeah, yeah.
So that's how I fixed it. Yeah, I
All right.
fixed this problem.
All right.
Yeah.
Job well done, Ioana. So very, very nice presentation, and I really like the way you got into the details. So I'm just gonna
Thank you so much.
so just hang on. I'll finish. All right, everyone. This was Ioana's presentation, and very, very nice. So a warm congratulations to her. I want to encourage all those of you who want to try this course as well as this project to do the same thing and get the courage to come and make your own presentation as well to show us your implementation, and that way you also gain a lot of understanding about the work that you have done. So until next time, keep pushing your ROS learning. Bye bye.